Hello everybody, welcome to my new video. It's going to be solving another Codeforces problem, this time a D4 contest, which is significantly easier than D2 or even D3. That's the eighth problem. It's called Scuza or whatever, I don't know how to pronounce it. Timur has a stairway with n steps. The eighth step is a of I. Meter is higher than its predecessor. The first step is a1. Meter is higher than the ground, and the ground starts at 0 meters. See? So yeah. So here that's for example, this one is how high this step is from the ground, and this is from this step, and this is how high it compared to this step, and this is how high compared to this steps, and this representation makes it pretty understandable and pretty clear now. And also now we can see the constraints. We have test case is 100 to the power of 2 multiplied by 10 to the power of 5. Here, the second line of each test case contains n integers, the height of the steps. The third line of each test case contains q integers, the number for each question. It is guaranteed that the sum of n does not exceed 2 multiplied by 10 to the power of 5, and the sum of q does not exceed 2 multiplied by 10 to the power of 5. Anyways, for each test case, I'll put a single line containing q integers, the answer for each question. And like for each question, it said, for example, you have to print the maximum possible height Timur can achieve by climbing the steps. If his legs are of length k of I, it means that while climbing, he he can go to the next step only if the length of his step, like if the jump that need to be done is lower or equal to the strength of his legs. Yeah. So here, for example, if we have the strength of his leg is 1, is 2, I mean, here it's up with 2, yeah. If the strength of his legs are 2, he can go to the step. Otherwise, he can do that. Anyways, okay, and we can do some quick observations here. Like, say for example, if this number, this is the maximum high, the maximum jump that we should do. So here, for example, we have to do this whole jump. Each time, I'll be like, if you know perfect sum, it's like summing all the previous sums of the previous elements in a way. We'll be doing the same thing but with maximum and minimum, in a way that for example, the array will be something like this. This is 1, this is 2, the max here is 2, here the 1, the max stays 2, and 5, it will be 5. And then we can do something called binary search, and we'll search for the which element that will like which index can have the higher number that is less or equal to the strength of his legs. Yeah, that's why. And then after finding the index, we can do perfect sum for all of this to find the exact height of each step, like it's summing all the previous sums. Yeah, that's the thing we gotta use. Yeah, let's start implementing the solution. If I forgot something, I'll remember it then. Because this is my first time solving the problem. As you can see, I just submitted a compile error just so I could find the problem again because it's null contests. Okay, now simply go turn 0, see out the say, and here we'll be doing how many cascades max is going to be. While the next one is going to be we do this function, we will call it solve, like everybody does this. Okay, now n q, n is the number of students and the q is the number of q is the number of what, q is the number of questions. Let me see. Yeah, that's right. So let us make a vector v of n elements which will store the states, like the height of each step compared to the previous one. Then we'll do another vector. Wait, the questions. The question will be done in while q minus minus will be processing the questions. X and syntax. Those are the questions. Now let us vector of n. Anyways, they said that we need to use a long, what do you call maths like this. Then we need to use long, so we'll define int as long. That's the okay. Now, what else should we do? This vector should initialize it with the n elements, and all of them are 0, normally 0, yes. Then all 0 for j, yeah, up with the max of g is equal to max of g and a of g, which means that for each oh, it's not a 3. For each index, I'll be knowing, like, if, for example, I could like have, let me make an example that will make why I did the Mac thing. Because, for example, look, I think that I should use the draft IO to make an example. Imagine that we have, like, it's a test, so normally it should be sorted. So now we have something like this, then something high like this. Like the jump is very high. Okay, wait. Yeah, the jump is very high. But then you can do something like this. Like I can make another jump, but this time it's pretty slow, pretty pretty not, pretty small, yeah, pretty small jump. Like this, you can see now the difference. So now, if I want to go to reach this step, if I want to reach this step, this one, then I should reach this one so I can go here. But if my legs are not long enough to reach this one, then I cannot reach this one, meaning that the highest will be here. And that's the whole observation about this problem. Like, it's a pretty nice problem. And I also have a lot of problems to propose. Yeah, a lot of nice problems for my nice viewers that are 10 or 15, whatever. But anyways, thank you for the 10 viewers that are watching my videos. Thank you for all of you. Thank you. Okay. Now, okay, I hope that you understood what's the point of uh, the point of why we should do the max thing. Okay. Now, yeah, like me, I don't know, yeah, lower bound will do it. Like binary search, there is a we call it function that is lower bound. It will show us the it uses binary search, but it's already built in the C++ bit C++ that each, so it should work. It should work. Now, to find the index, we will use lower bound. Lower bound, or maybe use upper bound. Yeah, we will use upper bound, and I know why. So, for example, we have this index. Okay, so is there something when I cannot reach anything? Okay, see, now has no legs, so he cannot go up even a single step. That's actually another if edge case we have to do in the upper bound. The thing about upper bound, it will in a sorted array, a max thing, it will always be sorted anyways. It will show us the number that is strictly bigger than that number in the array. It will show us the index of it. Then we simply have to do -1 of that index to find the the first element, the last element to be equal that, or the last element to be the last element to be lower than it, like the biggest element that is lower than it. So upper bound max dot begin, max dot end. Okay, and we need to find what? We need to find x minus. We will do. You know what? Let us keep it as an iterator and call it. Like I like to call iterated with it. Yeah. Now, simply we will see if it is equal to max dot end. It means that there is no element in the array that is bigger than that one. So we simply will see out the last element of the max array, which is max n minus one. Okay, if that way, or okay, yeah. Now we do another one. Else if it is equal to uh, max dot begin. What does it mean? It means that the only element that is bigger than the only element that is bigger than x is actually the first element. So there is no element that is smaller than or equal to x. It means that there is he can jump uh, anywhere. So we will see out 0. Now else it should be pretty normal, and we will just simply say out max of we will say out the it minus 1. Okay, like this. Oh wait, there's something that I'm missing. I forgot it. Like when I said that thing about Vixam, I'll be doing it now. Vector of int prefix and elements, they start all at 0. Or in j is equal to 1. Okay, so prefix of j plus a prefix of j minus 1. It will give us prefix sum. This is called. Now we simply here we'll be doing prefix n minus 1, and here we'll be simply doing uh, we will find like the index of it. It should be it minus max to begin. It's zero base, so it should work. And then what to do? Yeah, then simply see out the prefix of 8 minus 1, and it should work. I mean, it edx. Okay. It's taking too yeah, it compiled now. Okay. Tell me in the comments whether you're interested in trying to correct the at code contests. So okay, here what are the answers? They are all zeros. Okay, that's odd. Very odd. What is okay, there's something that I'm missing. Yeah, that's the problem about prefix. It's more forgot it needs to be related to the. Actually, this prefix array is we can simply use our vector v to yeah, but you can also do the second array, but that's basically the same thing. But just to save memory, you know. Okay, so got I v same here v and should work. Should work. Okay, so what did we have? What did we got as an answer? They pretty wrong answers. As I'm seeing, 1449. Why am I getting 4499? Okay, so there's something that I'm fishy. Okay, what else? 22. Okay, 02. That's right. Yeah, this 31. It gave us, yeah, right answer. So there's obviously one mistake. We'll have a short pub and then we'll come again now. So here I am back now. Yeah, I just had something pretty important to do. Now let me see. I think that the problem is in here because now max of it's already initialized at 0. So I guess we should start it as 1, and the max of j is the max of v of g and v of g minus 1. Yeah, and the max of 0 is the first element himself. So it's v of 0 should work, I guess. Like, I make a lot of mistakes in front of you, but that's beneficial for both of us. Let me drink a bit. Okay, so that's what those are right answers. See, this is how a competitive programmer should think, should debug. I'm not that like idol of competitive programmer. I'm pretty newbie. I'm a newbie, but and I have to admit that. But like for my peers that are very beginners, like they just started CP, then I just show to them that prove to them that CP like it's thinking, it's things like that. Okay, Scuza, nice. It should work. What is the what's wrong? They found that. What's wrong with my code? Yeah, just found my the mistake in my code. Yeah, this way it should work. Pretty sure. I think that like soda helps us things. Like I remember that guy we had in Olympiad in CP and okay, yeah. I think that's wrong. Mm, mm. To start at zero. This is the thing about it, and then with and yeah, we gotta do something. Reason is equal to max object. Something like this should work. Okay, so now that should be okay. I will do other stuff than DSU. If you know France UI, yeah, we got accepted, finally. If you know France UI, then we'll be doing a France UI problem. Thank you for watching anyway, and bye. Bye.